ATR landing gear is a retractable tricycle fuselage-mounted type. It is electrically controlled and hydraulically actuated. Main landing gear, MLG, is of lever type inboard retracting, partially below the passenger compartment floor and partially in a specific fairing. Each main gear assembly is equipped with 2 wheels and an oleo-pneumatic shock absorber. Nose landing gear, NLG, is forward retracting. It is housed in a wheel well aircraft nose. The 2-wheel nose gear assembly includes an oleo-pneumatic shock absorber. Landing gear extension and retraction is controlled by a control lever located on the center instrument panel. The landing gear is actuated by the hydraulic system. In the event of a hydraulic power supply failure, an emergency extension system is provided. In case of hydraulic or electrical supply failure, the landing gear can be extended by gravity and aerodynamic force. Nose landing gear and main landing gear extend and lock down with their free fall assisters' help. In the flight compartment, a push-pull handle permits landing gear mechanical unlocking. The 4 main gear wheels are equipped with multi-disc steel brakes, each operated by one set of 5 hydraulical pistons. 2 modes are available: normal braking mode. It is controlled by pilot's brake pedals and supplied by the green system. Emergency and parking braking mode. It is controlled by the emergency and parking brake handle and supplied by the blue system. Each brake is equipped with an automatic adjuster, a wear indicator pin, and an overheat detector. The wheels are fitted with tubeless tires. The main gear wheels are braked automatically as soon as the pilot selects the landing gear up. The main gear wheels are fitted with fusible plugs which protects against tire and wheels burst in case of an overheat. These fusible plugs are designed to release internal pressure when wheel temperature exceeds 177 degrees Celsius, 350 degrees Fahrenheit. The anti-skid system is activated as soon as the gear is down and locked, and as long as the aircraft speed exceeds 10 knots. Each wheel and each pair of external or internal wheels are monitored. The aim of the system is to provide the maximum stopping performance by controlling brake pressure in order to minimize wheel slip, brake and tire wear, depending on runway conditions. Touchdown protection is ensured. Spin-up locked wheel. The system consists of 4 wheel speed transducers, 1 per main gear wheel, 1 control box, 1 anti-skid module. A reference velocity signal is generated. The anti-skid applies a deceleration law, continuously adapting the actual wheel speed to the reference speed. The hydraulically actuated nose wheel steering system is controlled by mechanical linkage from a steering tiller handle on the captain's side panel. Nose wheel steering is manually controlled, hydraulically actuated, and electrically disabled. The nose gear has a range of 60 degrees to either side of center. In addition, nose wheel deflection of 91 degrees is possible during towing with no pressure in the system. The landing gear position detection and indication consist of 2 independent systems. The primary system is managed by MFC Module 1A. The associated gear position is displayed on the main instrument panel. The secondary system is managed by MFC Module 2A. The associated gear position is displayed on the overhead panel. Each system uses its own detector and indications. downlock and air-ground signals from proximity sensors, uplock signal from mechanical limit switches. Each system commands gear extension and retraction, gear anti-retraction system, and the warning associated to landing gear not down. Note: gear must be considered down when one system indicates 3 green lights. Each system has its own weight on wheels circuit, weight on wheels 1 into MFC module 1B, and weight on wheels 2 into MFC module 2B. The weight on wheels signals are used by the MFC to have the system using weight on wheels information switched to the appropriate air-ground configuration. On ground, during walk-around, landing gear uplock boxes must be checked. The landing gear uplock box in closed position leads to the red local unlock alarm light in the cockpit. The uplock box can be opened by pulling the landing gear emergency extension handle. Then, replace it in its initial position. During walk-around, do not forget to check brake wear indicator pin. For more information about landing gear controls, click on the cockpit location labels. Landing gear system is composed of nose and main landing gear and doors, landing gear extension and retraction system, wheels and brakes, nose wheel steering system, position and warning system. For monitoring and controlling functions, the landing gear interfaces with the electrical system. The hydraulic system supplies hydraulic pressure to the landing gear system. Green system is used for normal braking system and landing gear operations. Blue system is used for parking and emergency braking operations. Hydraulic external power is used to perform landing gear extension and retraction tests on ground. On right-hand maintenance panel in the cockpit, a selector enables the weight on wheels to be selected to the in-flight position, FLT, when aircraft is on ground for maintenance purposes. Warnings and cautions from landing gear system are displayed on the crew alerting panel. This module gives general information about ATR family features. With no hydraulic power supply, landing gear can be released from the uplocked position by an emergency system. When released, both nose landing gear (NLG) and main landing gear (MLG) extend by their own weight and free-fall assisters. Maximum takeoff weight and maximum landing weight are almost the same due to strong landing gear structure. When aircraft is jacked, for maintenance purposes, weight on wheels switch must be set to flight position to accept electrical external power from ground power unit, GPU. Nose wheel steering is operated by the blue hydraulic system. Control is achieved using the steering control hand wheel mounted on the captain's lateral console. A guarded switch located near the back of the steering hand wheel is used to depressurize the steering system if required. If the aircraft has to be towed with pressurized blue hydraulic system, nose wheel steering must be in off position. If the blue system is lost, the aircraft can be guided using differential braking and engine thrust. An internal mechanism returns the wheel to the centered position when the aircraft is airborne. Normal braking uses hydraulic pressure from green system. Pedals control normal braking. Note, each brake is equipped with a wear indicator pin. The normal system uses an anti-skid system which controls the hydraulic pressure for maximum braking efficiency. The anti-skid is available as soon as the gear is locked down. Ground speed must be greater than 10 knots. It operates by individual control of each wheel with coupling by internal and external pairs. The anti-skid system is controlled and monitored from a panel located on the center instrument panel. Anti-skid push button controls activation of the anti-skid system. Touchdown protection. At main gear compression, the braking action is inhibited as long as wheel spin does not exceed 35 knots. This inhibition is limited to 5 seconds maximum. Anti-skid amber light illuminates and the CCAS is activated when anti-skid is lost on associated channel. Note, in case of electrical supply loss of the anti-skid system, the brake can be directly pressurized. Now, please select Anti-Skid Test push button. The test duration is approximately 6 seconds on ground and 3 seconds in flight. If the channel fails, associated fault light remains illuminated. Note the test is inhibited when wheel speed exceeds 17 knots. Caution: if parking brake is not applied, the anti-skid test will cause a loss of normal brake, so the plane can move.
The brake temperature is located below the anti-skid panel. Hot amber light illuminates, and CCAS is activated when brake temperature is higher than 160 degrees Celsius. Reset temperature equals 150 degrees Celsius. Please select Brake Temp push button.
When the brake temp push to test push button is depressed, caution amber light, wheels on cap, hot amber light illuminates, and single chime is triggered. Emergency and parking braking is supplied with hydraulic pressure from blue system. Brake lever on center pedestal controls emergency and parking braking. Out of emergency and parking notches, the lever is spring-loaded to off position. Please select brake lever to emergency position. From off to emergency position, the pressure sent to brakes gradually increases up to 500 psi. As soon as the lever is no longer in the brake off position, parking brake amber light illuminates on the cap. Please select brake lever to parking position. At parking position, 3000 psi is applied to the brakes. If the blue circuit is not under pressure, the braking accumulator allows, at least, 6 brake applications at full braking pressure. Accumulator pressure is monitored by the triple indicator on the center panel. The nose and main landing gear are hydraulically operated, green system. Located on the center instrument panel are primary indicating system, landing gear lever. Secondary indicating system is located on the overhead panel. Now, let's perform the pattern. 3 greens. We are lined up for takeoff. Aircraft takeoff has been performed successfully. Positive climb is established. Please set the landing gear lever to up position. 2 isolated systems, 1 and 2, indicate the landing gear position. System 1 on the center panel. System 2 on the overhead panel. Each unlock red light illuminates when respective gear is not locked in lever selected position. On ground, the uplock box is not in the right position. Note, as soon as the lever is selected up, the main gear wheels are braked automatically. Green lights are extinguished. Landing gear is now up and locked. Now, carry on with the pattern. Alarm is activated if flaps equals 15 degrees or 30 degrees according to the model and radio altimeter altitude less than 500 feet, or at least one power lever at flight idle and radio altimeter altitude less than 500 feet. Now please clear master warning on cap. Set landing gear lever to down position. Each unlock red light illuminates. Landing gear is traveling. Green lights illuminates. Landing gear is down and locked. Aircraft can be landed safely. Let's go for landing. Okay, good landing. End of landing gear system operation in normal condition. The nose and main landing gear are hydraulically operated, green system. Located on the center instrument panel are primary indicating system, landing gear lever. Secondary indicating system is located on the overhead panel. Now, let's perform the pattern. 3 greens. We are lined up for takeoff. Aircraft takeoff has been performed successfully. Positive climb is established. Please set the landing gear lever to up position. 2 isolated systems, 1 and 2, indicate the landing gear position. System 1 on the center panel. System 2 on the overhead panel. Each unlock red light illuminates when respective gear is not locked in lever selected position. On ground, the uplock box is not in the right position. Note, as soon as the lever is selected up, the main gear wheels are braked automatically. Green lights are extinguished. Landing gear is now up and locked. Now, carry on with the pattern. Now, landing gear can be extended. In the event of normal system failure, the landing gear is extended mechanically. A guarded handle on the center pedestal permits mechanical unlocking. The extension is performed by gravity and the downlock is assisted by freefall assister. Set landing gear lever to down position. 2 greens only. Unlock red light is still illuminated. Both primary and secondary indicating systems display the same information. Nose landing gear is not extended. The gear must be considered down by the crew as soon as one system indicates it down. 3 green lights. Now, please follow appropriate procedure following failure. Landing gear lever, down. EMER extension handle, pull above pedestal level. Caution, do not twist the angle when operating. If the handle comes down, pull again and maintain up to green lights illuminated. TCAS, TA only. If unsuccessful landing with abnormal landing gear procedure, apply. In the event of normal system failure, the landing gear is extended mechanically. The guarded handle on the center pedestal permits mechanical unlocking. Landing gear extension is performed by gravity and the downlock is assisted by freefall assister. Well done! All is down and locked. Let's go for landing. Okay, good landing. End of landing gear system operation in abnormal condition. The nose and main landing gear are hydraulically operated, green system. Located on the center instrument panel are primary indicating system, landing gear lever. Secondary indicating system is located on the overhead panel. Now, let's perform the pattern. 3 greens. We are lined up for takeoff. Aircraft takeoff has been performed successfully. Positive climb is established. Please set the landing gear lever to up position. 2 isolated systems, 1 and 2, indicate the landing gear position. System 1 on the center panel. System 2 on the overhead panel. Each unlock red light illuminates when respective gear is not locked in lever selected position. On ground, the uplock box is not in the right position. Note, As soon as the lever is selected up, the main gear wheels are braked automatically. Green lights are extinguished. Landing gear is now up and locked. Now, carry on with the pattern. Alarm is activated if flaps equals 15 degrees or 30 degrees according to the model and radio altimeter altitude less than 500 feet, or at least one power lever at flight idle and radio altimeter altitude less than 500 feet. Now please clear Master Warning on cap. Set landing gear lever to down position. Each unlock red light illuminates. Landing gear is traveling. Green lights illuminates. Landing gear is down and locked. Aircraft can be landed safely. Let's go for landing. Okay, good landing. End of landing gear system operation in normal condition. The nose and main landing gear are hydraulically operated, green system. Click on the first page of the FCOM for more information about landing gear electrical supply. Have a look at the overhead and the center panel. Gear position secondary system. It is controlled by multifunction computer 2. Unlock red light, gear not in selected position, or uplock box not opened on ground. Green light, downlock engaged. Gear position primary system. It is controlled by multifunction computer 1. Unlock red light, gear not in selected position, or uplock box not opened on ground. Green light, downlock engaged. Landing gear lever. The lever must be pulled out prior to selecting the two possible positions. Up, the landing gear retraction is selected. Down, the landing gear extension is selected. Gear handle red light illuminates when any gear is not sensed down and locked with RA less than 500 feet. A latch prevents selection up on ground. Have a look at the center panel. Anti-skid channel's fault lights illuminates amber and the CCAS is activated if a failure is detected in the associated channel. Anti-skid is lost on the associated wheel. Anti-skid push button. It controls activation, deactivation of the anti-skid system. Push button pressed in. Anti-skid system is activated. Off white light illuminates when push button is released. Anti-skid system is deactivated. Test push button. Press the push button to initiate an automatic sequential test to verify the primary anti-skid protection capabilities of the system. Test duration. In flight 3 seconds. On ground 6 seconds. Caution: do not perform the test with engines running without parking brake set. The anti-skid channel fault lights illuminate during the test. If one channel is sensed as failed, the associated fault amber light remains illuminated. Note the test is inhibited when wheel speed exceeds 17 knots. Brake temp. Hot amber light illuminates and the CCAS illuminates when at least one of the brake's temperature exceeds 160 degrees Celsius. Have a look at the center pedestal near power and condition levers. Brake off position. The lever is spring-loaded to off position. Brakes are released. Parking brake amber light is extinguished on cap. Emergency position. A metered pressure is applied to the brakes. Pressure equals 500 psi. Parking brake amber light illuminates on cap. Parking position. Full pressure is applied to the brakes. Pressure equals 3000 psi. Parking brake amber light illuminates on cap.